we can move on. This one is also covered on the YouTube video, so I'm going to go through it really fast. But what are we doing? If you show this image to a human artist, they're going to be able to imagine what is missing. You're expecting the same thing from a computer. You can show it a lot of images and then use your usual L2 laws, treat it as a regression problem. It's going to solve it, but the solution is not perfect, or it doesn't look good. It's going to end up being blurry, and then you're going to know that this is not what we want. But if you use a generative process, you're going to be able to fill in the details. It's no longer blurry. Maybe the details don't make much sense sometimes, but even the drawing from a human being doesn't have those regularities of the original image. And this is information that is missed. Okay, perfect. And if you think about it, this is very similar to what we were doing with BERT type of language models. You would mask out some portions of your sentence, and then you were asking your language model to generate those missing words or those masked words. It's the same thing here. What you're going to be putting inside your encoder is the masked version of your image. It's going to give you a bunch of encoded features. And then here you have the option to flatten the result and then do a fully connected network on it. But then that's going to end up being costly. You flatten only your along your resolution, and then you're going to do your operations channel-wise. And this way you're reducing the number of parameters at the same time, operations. And then you're going to write down your loss function. So there is this trick that I want you to learn about how to actually mask. You're going to define a binary mask, which is going to be 1 whenever a pixel is dropped and 0 otherwise. So it's going to be 1 here, 0 everywhere else. And then whenever you want to mask out something, or you want to mask out the complement of that region, you are going to be using m times whatever was the output of your network, or whatever your image is, or whatever tensor that you want to mask. And if you want to mask the complement, you're going to say 1 minus the mask. And this is Hadamard product. It's going to be pointwise. And then the rest of it is training this, and then you're going to be able to fill in the details. Not only that, this process is going to give you very good features. So you're doing feature learning without having any labels. You can think of it as a self-supervised framework. The self-supervision signal is coming from the image itself, not from outside labels. And then those features, you can start analyzing them. Maybe put a small classifier on top of it and see what is going to be your performance. It is not perfect when it comes to classification, detection, or segmentation. It is still far below what you would get out of having supervisory signals like labels, but it's actually not that bad. And later on, we're going to improve upon this when it comes to self-supervised learning. Any questions? Was everything clear? Okay, cool.